All right, so here is going to be our walkthrough for the assignment titled More Chain Rule. This is going to be some fairly basic chain rule problems using trig functions, exponential functions, and logarithmic functions. So we're going to start off here with this one, y equals the sine of 5x. To find its derivative, we'll use the chain rule. It's the sine of u, where u is equal to 5x. Right? So we'll find dy du. Derivative of sine is cosine. Should have that one memorized. And the derivative of 5x using the power rule is just 5. So our final answer is dy dx is equal to 5 times cosine u. Well, u is 5x. So we get 5 cosine of 5x. For our second one here, we've got the cosine of 4x. So just like the previous one, this is like y equals cosine of u, where u is equal to 4x. So our derivative with respect to u of y is negative sine u, right? You should have that derivative memorized. And du dx is 4. So our final answer should be dy dx is equal to the product of those two things, negative 4 sine of u, where u is 4x. For our third one here, we've got the tangent of 1/7 x. So again, this is the exact same process. This is y equals the tangent of u, with u equal to 1/7 x. The derivative of tangent is another one you should have memorized. It's secant squared. So derivative of tangent is secant squared u. And the derivative of u with respect to x, that's just 1/7. So multiply them together, and your final answer should be dy dx equals 1/7 secant squared of 1/7 x. And hopefully you kind of are seeing the pattern here, right? That we're just ending up with the derivative of tangent evaluated at the 1/7 x, and then we're multiplying it by the derivative of that thing that's inside, right? You should be getting to the point where these pretty straightforward ones are doable in your head, I would hope. So for our next one, secant of x squared, I'm going to keep writing them out even though I'd like you to be able to do these in your head. This is y equals the secant of u, where u is equal to x squared. So we're going to take our derivative of secant u. Well, that's going to be, I should write dy du in front. That's going to be secant u tangent u. And then our derivative of u is just going to be 2x. So as we multiply these together, we'll get dy dx is equal to 2x secant u, or secant x squared, tangent u, or tangent x squared. And that should be our final answer there for number 4. For number 5, we've got the cotangent of 5x cubed. So once again, this is just going to look like y equals the cotangent of u, where u is 5x cubed. We should know the derivative of cotangent is negative cosecant squared. So we've got dy du equals negative cosecant squared u. And we've got du dx is equal to 15x squared. So again, when we multiply those together, dy dx should be negative 15x squared times the cosecant squared of u, where u is 5x cubed. And that should be our final answer for number 5. For number 6 here, once again, we've just got the similar type of problem. It's y equals the cosecant of u, where u is equal to 10x. And this is our last of the 6 trig derivatives. Right? Last one we haven't used yet. We should know that dy du on that is negative cosecant u, cotangent u. You should have that derivative memorized. And then the derivative of the 10x is, of course, just 10. So when you multiply these together to get your dy dx, we'll have negative 10 cosecant u, where u is 10x, times cotangent u, where u is still 10x. So negative 10 cosecant 10x cotangent 10x. For number 7 here, we've got cosine of x cubed plus x squared. So again, this is just y equals the cosine of u, where u is a slightly more complicated function, but nothing too terrible, x cubed plus x squared. So dy du should just be negative sine u, because we have that memorized. And with the power rule, we should get 3x squared plus 2x, or x cubed plus x squared. So our final answer here for number 7 should be a negative sine of our x cubed plus x squared. And that whole thing is getting multiplied by our du dx, 3x squared plus 2x. And I'll write my dy dx out in front. There's our final answer. For number 8 here, we're just going to rewrite this using the chain rule. We've got sine of u, where u is 3x to the 5th, minus 7x plus 1. The derivative of our sine u is cosine u. The derivative of our 3x to the 5th is 15x to the 4th. And then we have a minus 7, and then the plus 1 goes away because the derivative of a constant is 0. I didn't do this on the last one, but normally with these, I'll try and write the 15x to the 4th minus 7, that little polynomial function out in front. And then we'll put the cosine after, because sometimes if you don't do the cosine after, it kind of makes it look like you have both of those things inside the argument of the cosine, whereas we want to make it clear that the 15x to the 4th minus 7 is just being multiplied by that cosine. It's not part of the cosine. All right, we're going to transition here to some exponential functions. These are all pretty basic ones. This is just y equals e to the u, where u is equal to 5x. It's just the chain rule again. We should by now have the rule for the derivative of e to the u, or e to the x, memorized. Right? It's just itself. So the derivative of e to the u with respect to u is e to the u. And then the derivative of 5x is just 5. So our final answer here should just be the product of those two things, 5 times e to the u, where u is 5x. For number 10, very similar to the last one. This is just y equals e to the u, but u this time is negative 1/2 of x. So when we take the derivative of the y, we get dy du is equal to e to the u. And when we take the du dx, we just get negative 1/2. Multiplying those two things together, our final answer should just be negative 1/2 e to the u, but u is negative 1/2 x, so we get negative 1/2 e to the negative 1/2 x. And that is problem number 10. We are halfway finished with these. We'll do a couple more exponential ones here. So we've got e to the 5x cubed. That's y equals e to the u, where u is equal to 5x cubed. Our derivative with respect to u of e to the u is just e to the u. Again, should have that rule memorized. The derivative of u with respect to x is just a power rule problem, 15x squared. So just multiply them together and you get dy dx is 15x squared e to the 5x cubed. All right, for 5 to the power of 8x. This one is, again, an exponential function. It's of the form a to the u, where a is equal to 5. And so we've got u is equal to 8x. We'll just take the derivatives. You should know the derivative of a to the u, right, or a to the x. I'm just going to write it off to the side here. The derivative of a to the x is a to the x natural log of a, right? So if I want the derivative with respect to u of 5 to the u, that should be 5 to the u times the natural log of 5. And then we'll just find du dx, which is 8, using the power rule, and multiply those two things together. So we end up with 8 natural log 5. We'll put a dy dx in front. Dy dx is 8 natural log of 5 times 5 to the power of 8x. For number 13 here, we've got pi to the x squared. Well, pi is just a constant, so this is in the form of a to the u, where u is x squared, and pi is equal to a. So our derivative here for the y term, dy du, should just be pi to the u times the natural log of pi. And our derivative of u, du dx, should just be 2x. Then we'll just multiply these two things together. So we end up with 2x ln pi times pi to the x squared. And that should be our dy dx. 2x ln pi times pi to the x squared. All right, here we've got 10 to the x squared minus 3. So again, this is another exponential function. This is y equals 10 to the u, where u is equal to x squared minus 3. So we'll take our derivative with respect to u of y, dy du, should be 10 to the u times the natural log of 10. And our du dx should just be 2x. So we end up with 2x ln 10 times our original function, which was 10 to the x squared minus 3. And that should be dy dx. All right, now we'll move into a couple of logarithmic functions, just some sort of basic logarithmic functions. Right? Natural log of x cubed. Right? So two ways to look at this. One is to write it as y equals the natural log of u, where u is equal to x cubed, and use the chain rule. Right? So the derivative of natural log u, that's the one we should have memorized, is 1 over u. And du dx is 3x squared. So our result is just the product of those. 3x squared over x to the third, or just 3 over x. But as I mentioned, there's another way you could look at it. We can always rewrite this using log rules before we even take the derivative. We have a log rule that says if we have an exponent inside of the logarithm, we can pull that exponent out. So this is equivalent to just 3 ln x. Well, the derivative of 3 ln x is just the constant times the derivative of ln x, which is 1 over x. So either way, you get the same answer. Whichever one you prefer is absolutely fine with me. For number 16, this time we can't use a little trick to rewrite it. We just have to do y equals the natural log of u, where u is the sine of x. So dy du, just using the rule for natural log, is 1 over u. And du dx, using the trig derivative rules, is just cosine x. So we end up with the product of those two things, which is cosine x times 1 over sine x. And of course, we can rewrite that as cotangent x. All right, just a couple more here to go. Here's number 17. this is y equals the natural log of u, where u is x minus tangent of x. So dy du will be 1 over u, just like it was for all the other ones. And du dx will be 1 minus secant squared of x. So when we write this out to find dy dx, we'll have 1 minus secant squared x in the numerator, and in the denominator, we will have our original u, which was x minus the tangent of x. And that should be it. For our next one here, we've got a slightly different function. So it's no longer natural log, it's log base 7. But that's fine. We have a rule for that, right? The rule is if I want the derivative of log base a of x, that should be 1 over x times the natural log of a. Right, so we're going to use that rule here in conjunction with the chain rule. We've got y equals log base 7 of u, where u is x cubed minus 1. So we'll first start off by using the log derivative rule here. It says this should be 1 over u times the natural log of the base, which was 7. And then we'll multiply that, and we write that that's dy du. And then we have du dx. We'll multiply by these two things by each other. The derivative of x cubed minus 1 is just 3x squared. Now we'll find the product here. So it looks like that's going to become dy dx is equal to 3x squared over x cubed minus 1 times the natural log of 7. And that should be our final answer for that one. All right, just two more to go. Number 19 here, we've got y equals the log base 10 of u. Note that anytime we don't have a base written there, that's log base 10. We'd also call it common log. I'm going to put it in there just so that we see that for when we need to do our natural log in the denominator. So it's log base 10 of u, where u is x squared plus x plus 1. So dy du should be 1 over u natural log 10. And then du dx should just be 2x plus 1. So when I multiply those two things together to get dy dx, I should end up with 2x plus 1 over x squared plus x plus 1 times the natural log of 10. All right, and our last one here, we should just be able to write this as y equals log base 3 of u, where u is 3x cubed minus x. So our derivative of log base 3 of u should be 1 over u natural log 3, just from the rule that we should have memorized. And then du dx will just be 9x squared minus 1. And if we multiply those together to get dy dx, we'll have 9x squared minus 1 over 3x cubed minus x times our natural log of 3. And that should be our final answer. I know we can factor an x out of that denominator and get a 3x squared minus 1. We could also use a difference of cubes on the numerator. But if we do that, nothing's actually going to end up canceling out. And so not really necessary to factor it out unless you just feel like doing it. So that is the end of our more chain rule homework walkthrough. Mostly fairly easy chain rule problems, just kind of making sure we have our derivatives of trig functions and exponential functions and logarithmic functions all memorized. So if you don't have those memorized, you need to.